let's talk about exploring your data. Okay, there are several functions that you can use to explore your data. Those that have asterisks are the ones that I like more because they give you more information about your data set. For instance, you have str, PTS, and what this tells you is the structure of your data. It's gonna tell you, look at here, it's gonna tell you the name of your variables, the type of data that these variables have. For instance, country is a factor, year is integral, and if you had here something like a numeric kind of variable, it's going to tell you it's going to be numeric or continuous, which is a better name. And also it's going to tell you the actual observations, but the first rows. Okay, that's the structure. I like it. This one is or can be useful when you're exploring your data. You write PTS again, but I want to show you something here you can use. So I'm gonna run it first. So head shows you the first rows of your data set. In this case, it's gonna show you 6, but you can change this and tell the system that you want the first 10. Okay, so it's gonna show you the first 10. Similar is tail. Tail is gonna show you the last rows. Okay, but I think it's more useful this summary function. The summary function is going to give you some basic descriptive statistics of your variables. Obviously, when these variables are numeric, or at least are like you are using numbers, or you have assigned numbers to your variables. Okay. It's going to show you just the median and the mean and the minimum and maximum values, but also gives you when you have missing information, which is interesting. Okay, that's summary. I want to show you something else related with summary and introduce an operator that is critical in R, and is the $sign operator. The $sign operator allows you to call an object that is inside another object. I know that this sounds kind of weird and crazy right now, but it's gonna make sense. What happens is that your dataset has other objects, which are variables, right? Let's see it again. Any one of these, like a country, all of these variables are objects in themselves, okay? So you can go and tell R to select not the whole PTS dataset, but just the variable called year. And it's gonna summarize specifically year, okay? And that's important to keep in mind. dim is also useful. It's gonna tell you the number of rows and columns that you have in your dataset. Sometimes it's just to check very quick what you have. And the other one that I think is useful is names. It's gonna tell you the names of the variables. That's very important when you're processing or you are transforming your variables and you just forgot the name of one of the variables. Here is very simple because you have 13 variables in PTS, but sometimes you have data sets with 300 variables. So it's gonna be crazy. You're never gonna learn all the names of the variables. Okay. These are some of the functions to explore your data. Okay. You use these functions, and to some extent what you want to do is to know what kind of data set you have. Probably you already know, but sometimes you don't know what you're gonna encounter. And I want to talk about 3 different types of structures in datasets. The first structure is called the cross-sectional. The cross-sectional is when you have observations for different subjects of your unit of analysis at one moment in time. Okay? In this case, dataset number 1 used mock data that I created about the 4 corner states in 1993. Okay? So you have Arizona, Colorado, New Mexico, and Utah. and you have information about the population, crime, and GDP in 1993 that I created. Okay. The second type of structure is what is called time series. In this case, you have observations for the same subject of the unit of analysis across time. The dataset number 2 has information for Arizona from 1993 to 1996. I also created this information. And finally, you have, which is the most common type of data that you have usually, the time series, cross-sectional, or panel data. Okay. In this case, you have observations of different subjects across time. And notice that you have, for instance, here, Arizona 1993, Arizona 1994, Arizona 1996, and later you have New Mexico 1993, and so on and so forth. In this case, when you have this kind of a structure, your unit of analysis is not Arizona. It's not the year. It's both. Is the state year level. Okay? That's going to be your unit of analysis, because the combination of the state and year level or information is going to be the most basic indicator of one observation in your dataset. Okay, so it's not going to be repeated the information of Arizona 1993 again. And that's going to be different to Arizona 1994 and to New Mexico 1993 and so on and so forth. Okay, so we imported our data or loaded our data. We explore our data. Now we need to know if our data is tidy. But what is tidy? What is tidy data? Tidy data is data that is rectangular or tabular, that have, for each column, have, or better, for all the rows have the same information for all the columns, right? So you have information for all, or yeah, it's rectangular, like you don't have any missing piece of information. Look at the example of the non-tabular data in the right side of the screen, right? You don't have information for some rows about one variable or something like that. So you have like a different pieces of a puzzle, and you don't have a complete data set. And this is problematic because you're not going to be able to conduct the statistical analysis because you don't have the same structure. Okay. Another way to think about tidy data is when, and it's going to be more precise, and at the same time it's going to be more difficult to understand it right now, but I hope that over time you're going to be able to identify so much better which data sets are tidy and which are not tidy. And I'm going to give you at the end of the lecture some examples of untidy data. But basically what you want to have is that each variable in your data set has a column. Okay. Similarly, each observation of your dataset is going to have a row, and you're not going to have two rows for the same observation. And finally, each value has its own cell. Okay, so imagine that we have a tidy data, because as I said, untidy data is difficult to shape, but you need to learn later how to shape it. Okay. Usually, even if the data is tidy, such as in this example, you're going to have problems with that data. The data usually is dirty to some extent. There are inconsistent values, such as in this case, female, that is all in capital letters. Or you're going to have missing data, which is one of the most common types of problems with data. You can like designate different things for the missing data. You can have an empty space, or you can use the NA, or you can use the -99, so on and so forth, right? So that's problematic because you're not going to be able to conduct your statistical analysis. So what do you do with your dairy data? Especially, I'm going to focus here with your missing data. Because with inconsistent categories, such as female, to some extent, with variable transformation, you can clean your data set. Maybe we can talk about that later. This is a little bit advanced as well. But with the missing data is the most basic thing that you can do to clean your data, okay? There are several things that you can do with the missing data. The most basic thing, the simplest thing is just to delete all the missing data. And you use this function to do it, okay? Okay, so how do we do it? We create a new data set, a new object, and this object is gonna have a, I'm gonna call it, in this object is gonna have the data set but clean without missing values. Okay, I'm gonna use this function na omit, and here I have just the name of the data set. Many NAs you have in the PTS, and that's one of the problems that you have with the when you use the NA omit. Sometimes because of the nature of the data set, you're gonna have a lot of missing data. And if you use the case, like a case-wise deletion, you're gonna lose a lot of information. Look at this example. You have, let me see the structure of the PTS stream. Yeah, so you can see it also here. It changed. Now it's 355 observations, and it used to be 9,000. Okay, that's very problematic, honestly. For that reason, people have, like scholars have, used other methods, such as using the mean value for the numeric variables and the median for the ordinal and nominal variables. But nowadays, this practice has like a little support from the academic community. Like, not many people support that kind of solution to the problem of missing data right now. And some academics have created, some scholars have created new packages to solve these problems. These packages use statistical routines to solve the problem of the missing data by imputing, or for instance creating with Bayesian statistics solutions to these kind of problems. And one of the most common software is called packages is called Amelia, and you can explore it here, but it's at the same time a little bit advanced, and you need to study by yourself how to do it. We usually in this class we're gonna have clean data, already clean data, to make everything easier. But keep in mind that this is the real world kind of data that you're gonna have. Usually dirty and sometimes untidy data. Okay. Okay, so you clean your data, and you can do optional other steps. The first step is subset your data. Sometimes you need to, I don't know, you don't want to work with all the PTS data set. You just want to focus on some particular variables. So you create a new version of the PTS, and I'm gonna, in the reading materials, the author explained how to subset the data with the basic functions of R. I'm gonna give you another option, but it's the same. I don't care which option you use. Try each one and see what works better for you. It's something about flavors. Some people prefer tidyverse. The tidyverse is very popular right now because for some people, these functions are like a simpler, and they are better designed. So these people argue that tidyverse is very useful kind of package. For the reason I want to teach you this, but you can also use the basic functions. Okay, so we have the tidyverse, and we use the function select, and it's very simple. The only new thing here is that we are using this, I don't know, we are using this operator that is called a pipe, I'm gonna show you how to use it, but that's the only new thing that you're gonna have with this Tidyverse. Okay, so I'm gonna create the PTS3, and the PTS is gonna use the PTS, and I'm gonna create this pipe. I'm gonna say select, and which variables I want to use from the PTS. Let me see. Let's say that I'm gonna use country, year, and PTSA. Okay, country, year, and PTSA. Something wrong. Okay, I made a mistake here. Sorry, it's this one. Check that your coding is correct. Okay, so I created this PTS3. And my PTS3, as you can see, only have 3 variables. Only have country, year, and PTSA. Imagine that sometimes you don't want to have all the observations. So you want to select based on particular values of some of your variables, one or several of your variables. So you use the function filter in your Tidyverse. Okay. So I'm gonna create a new you don't well, I'm gonna show you that later. But you don't need to create a new variable each time you perform something in your dataset. You can even maintain your old dataset and perform a transformation. But if you do that, your PTS, your original dataset, is going to be transformed. So keep in mind that. Okay, so it's not going to be anymore with these observations and these variables. It's going to change. For that reason, I'm creating these new datasets anytime that I need it. Okay, so I'm going to use the function filter, and imagine that I want to focus only in the years after 9/11. Okay. So let's see my PTS4. So in my PTS4, I only have the years after 9/11. I want to see if the states increase their human rights violations after the year 2001. Okay. I want to introduce something that is important here. Anytime you control by the value of the variable, for instance, in this case, year has numeric values because you have, of course, like years like a 1999, 2000, so on and so forth. But for instance, a variable such as country has what they call factor variables or categorical variables. With categorical variables, what you do is to put in quotation marks the name of the value. Okay, because in this case, imagine that I want to focus in Afghanistan. What was that? Oh, of course. You cannot use greater than Afghanistan because that doesn't make any sense. And I'm going to do something here. Okay. So you create Afghanistan, right? So you filter by the country Afghanistan, and PTS4 only is going to have Afghanistan, right? Just to talk about what kind of a structure of data seems to be this one. Yes, it's correct. I hope you guessed that this kind of a structure is called a time series. You're going to have just one subject for your unit of analysis across time, okay, across years. It's just to review that concept. Okay. So I need to tell you something else that is important. When you use this kind of Boolean operators, or better, you can use Boolean operators to filter here, right? And I want to introduce you those Boolean operators. So you have less than, greater than, less than or equal to, greater than or equal to. And equal to is the equal sign twice. Not equal is this one, and this n and or are important because with n and or you can use multiple values of different variables or of the same variable to create a new data set. Okay, let's see one example of. So let's see, I have PTS4, no, let's use PTS5, which is PTS country. So I want my country to be Afghanistan and the year, again, to be before 2001. So look that the PTS5 is going to be 25 years before 2001 in Afghanistan. Okay? So this is important to subset your data. You can subset your data by using the function select and select some variables, or you can use different values of one or multiple variables and use the function filter. Perfect. And the final thing that we're gonna study this lecture is imagine that you want to export your data. So you manipulate it, for instance, you want to work just with this subset of the data set of the PTS. If you want to export it for any reason, because you invested a lot of time cleaning this data, making these manipulations, or even you transform your variables in a way that is significant for you and meaningful for you, so you don't want to do it again. You keep your code, but at the same time you want to upload your data set directly, so you need to export your data. If you need to do it, I suggest you to do it in a CSV file. Why CSV? Because CSV is a universal kind of data set that you can use in Excel, you can use in Stata, you can use in R, in SPSS, in any statistical software. It's very easy to manipulate, it's very clean, and even it's not heavy. It doesn't take a lot of like a space from your computer. So it's going to be better to use this kind of file, okay? And the way to do is just use this function, write CSV. You use the name of the object that you attributed to your dataset and the file, and you write the name of the how you want this dataset to be called, okay? So let's use the function. It's write.csv. What is the object? The object is the PTS5. And you create here, want to call this file, imagine that I want to call it PTS depurated Afghanistan 1976, I don't know, it was 2001, right? 2000. Okay. Always write the extension CSV, otherwise it's gonna give you an error. Okay, and you produce this and you like exported this dataset. Where is this dataset gonna be? Of course, it's gonna be in your working directory. Let's check it. Here is your dataset. Open it in Excel. This is your data. It's gonna be clean, it's gonna be nice. It's always gonna have this, is the number of observations that you have. Automatically is gonna create that column, but it's not a problem, it's fine. You just need to delete it and you have your clean dataset. Okay, great guys. I think this is gonna be helpful for you to have those building blocks of how to use R, or yeah, how to use R to explore, like load, import, and manipulate your data, and those skills to pre-process your dataset. Okay, as I said, the next lecture we're going to talk about how do you transform your variables. This is a long topic, so I need more time to explain that. And we're not going to have the space in this course to talk about how to reshape and tidy data, to be honest. I'm just going to give you basic information to help you to understand when a data set is tidy or untidy, I point to you the kind of softwares that you need to, I'm sorry, not software, the packages that you need to learn in order to tie your data. You can use the tidyverse again and use DYPLR, POR, or Tibble. But it's something that you need to learn in other courses, more advanced courses in statistics, or by yourself, okay? Okay, I'm gonna give you two examples of untidy data, and we wanna conclude the class with this. Dataset number one, for instance, is supposed to be a time series cross-sectional kind of data, and you have Peru for several years, for at least 1999 and 2000. But instead of having the variables deaths and attacks as different columns, you created a variable called type in which you have death and attacks, and a count in which you have 15 and 20. So you are duplicating observations. Okay. In the dataset number two, you have two values and an operator actually, and that's a mistake because you want to have the rate of the deaths and attacks. Imagine that it's terrorist attacks and the deaths related with those attacks. Okay, so those two data sets are untidy. How do you tie this data? You can do it if you reshape your data in a way that you have just one observation for this time series cross-sectional kind of structure in which your unit of analysis is country year. You have Peru, year, deaths, attacks, and the rate. This is tidy. You have, for each column, you have a variable. For each observation, you have a row. Okay? Okay? That's all, guys. So a brief summary. We learned how to load, import data. We didn't learn how to create it because we don't usually do it in political science, and it's not necessary right now for you. So I didn't want to give you information that probably you're not gonna use and it's not super relevant. Okay, so you know how to load, how to import. Later you know some functions to explore your data. You know and you distinguish between three types of data structures: cross-sectional, time series, and time series cross-sectional. Okay. Later you know and you distinguish between a tidy and untidy data. If your data is untidy, I encourage you to reshape it. Otherwise, you're gonna have big problems processing that data. Okay. Once you tie your data or your data is tidy, you need to clean it. This is required. It's not optional. If you don't have a clean data, you're gonna have, again, problems processing your data. Optional is that you can subset it, or you can create new variables or transform your variables according to your research interest, or you can export your data. Once you have done that, you can analyze. For the next lecture, we're gonna learn how to transform your variables. Okay, this is all, guys. What I'm gonna ask you for the next lab. For the next lab, I'm gonna ask you to download a dataset, probably in a CSV format because it's one of the most common, or maybe in the CSV and in a DTA format. Okay, you learn how to do it. You learn how to do it with the PTS. Okay, so right now you know tips. If when you download that data, put it in the folder in your working directory. Otherwise, you're gonna have problems. Okay, you know some functions to explore your data. Probably I'm gonna ask you to use some of these basic functions, especially those with asterisks, because I think those are the most important. I can ask you something like, in the, I don't know, dataset that you downloaded, tell me how many rows and how many columns you have. So what kind of function you use to do that? You can use dimension, for instance. Or I'm gonna tell you something like this. Tell me the names of the columns. So what kind of functions you're gonna use. And you learn to do that, okay? a more difficult type of question that I can, or task that I can ask you in the lab is something like this. Tell me what kind of a structure is this dataset. That's probably a more tricky kind of question. So if you have questions about what's the difference between cross-sectional, time series, and time series cross-sectional, ask those questions in the discussion board, okay? So keep in mind, I'm gonna give you tips what I'm gonna ask you about the labs, okay? I want you to know what is the difference between a tidy and untidy data, but I am aware that this information is so new for you and probably is not very important right now, okay? So don't worry about it. I'm not gonna ask you something complicated, or probably I'm not even gonna ask you anything about tidy and untidy data. Process this information, and maybe later you're gonna use it and you're gonna say, okay, I'm gonna see what I learned in a statistical class about this tidy and untidy, and explore and study by yourself how to solve this untidy kind of data, okay? What I want you to do, what I'm probably am gonna ask you to do, is to clean your data and maybe to perform some subsetting kind of tasks. So review what I just taught you about subsetting or exporting your data, because that's gonna be important. Now, I don't care if you use tidyverse or you use the basic functions that you learn in the reading materials, okay? As long as you are able to do it, that's fine. Okay, even if you go to Google and find another way to do it, that's fine for me. I don't care. The important thing is that you are able to do it. That's what I care. I don't care. All these materials are to help you guys to learn how to use R. That's really what I care. Okay? Okay, guys. So thank you so much for watching this video. Keep writing me in the discussion boards. I'm gonna use micro lectures, very short lectures, to reinforce things that maybe we have experienced problems, or to explain a concept that is probably problematic for you guys. But I want to ask you to keep asking questions, okay? If you are struggling with some of the contents of the class, don't worry, ask me those questions. And finally, if you want, I have office hours all Wednesdays from 2 to 3:30. These office hours can be physical. You can come here to my office in the core hall in Tempe and we can talk, or we can set an appointment and use Zoom and do it virtually. Okay? All the best. All the best, guys. Thank you so much. Bye.